Hello! Today we are going to have a look at some Analogue TV Demodulators. Now this video is going to be split into three different parts. Now first of all, we will cover some of the relevant theory behind these things. Then I'm going to put together a practical demonstration, and finally we'll open up this equipment and see what makes it tick. Now this video carries the usual warning that we are once again talking about things which are completely obsolete, and also we're probably trying to bite off a little bit more than we can chew here. But nonetheless, let's get stuck in. Now for those who watched my very first video, I talked about this stuff quite a bit, but a key concept we need to remember here is vestigial sideband modulation. And this is really how analog television signals appeared on air. So when we modulate a television carrier, we will, for argument's sake, end up with something which is around about 12 megahertz wide, so plus 6 megahertz from the center point and minus 6. Now the lower sideband, remember, is of course just a mirror image of the upper sideband and doesn't actually contain any information which is not in there. So the temptation, of course, was to just filter this off so that we end up using less bandwidth. Now doing so, of course, has its compromises. Now when we actually look at what happens in the receiver when we do that filtering, we have a slight problem. So for double sideband modulation, which is pretty much standard for AM, any kind of AM carrier, we actually, when we run this through an envelope detector, which is just rectifying the carrier, we do actually come out with a very nice clean representation of the signal which was fed into the modulator. However, when we filter off the lower sideband, there's quite a bit of distortion which happens here. So if we look at the red line, this is what happens with our envelope detector. We don't really have that nice clean sine wave anymore. It kind of looks a bit like a sine wave, but yeah, it's been distorted. Now this wasn't actually a particular problem back in the days of purely monochrome television. It became a problem when color came along, because you've got these very fine details being modulated into this carrier, and certainly these traditional envelope detector type receivers end up getting rather confused, particularly in areas with color. The solution to this problem is called synchronous demodulation. This is something that was pondered by RCA in the very earliest years of television. But the real problem was always building something that actually can do this and do it for a reasonable price. Now I wouldn't be surprised to hear that they probably built some kind of contraption which does this, but yeah, as I say, the actual commercialization of this came somewhat later. Now the idea here is that instead of using an envelope detector where we just run across the peaks of the carrier, what we do instead is we sample the carrier at specific times. The times, of course, are decided by this carrier tone down here. So if we sample where these dots are, we can actually recover the correct signal envelope. Now the problem with this is that this is really very quite a difficult thing to do, certainly with you know, sort of 1970s or earlier technology. Because in order to be able to correctly sample the carrier here, we actually need a clone of the carrier which was appearing at the transmitter. So how do we do that? Well, here's our very basic transmit and receive arrangement here. So we've got an input signal, a mixer or modulator, which is being transmitted to our receiver and demodulated. For synchronous demodulation to actually work correctly, this oscillator here in the receiver must be generating exactly the same tone that is appearing in the transmitter. And in terms of how that actually works, the carrier tone has to be extracted from the incoming signal. And this is a very difficult problem to solve. Now, as I said, one of the biggest challenges with synchronous demodulation was always just the commercialization of it. You know, how do you make something which does this for a price which you know, is palatable to the ordinary consumer? Now, anecdotally, I would say that the Philips company was absolutely key in bringing this technology to the markets. And they did that through integrated circuits such as this one here, the TCA 270, which, as far as I can tell, was the very first that they produced, which is doing this for the most part just in a single chip. So as it says here, this is a synchronous demodulator, and they actually give a circuit diagram of its internals. And yeah, as we can see, that this is not a trivial device. There's quite a lot going on in here for a chip of its era. If we go into the back page here, we've actually got an application information here, a circuit of how it's to be used. And just yeah, as a side note, these circuits were really very key to the design of consumer television equipment for many decades. Now, this is actually not the only product from Philips coming out in apparently here in 1976, which is doing synchronous demodulation. We actually have another rather interesting item to look at. So here we have the 1976 PTV catalogue, and this of course was published by the Danish Philips. Now in here we have a very interesting item, the PM5560, which is stated to be new this year, and of course it is a TV demodulator. Sounds rather unexciting, but this is a very exciting device for a number of reasons. Now, first of all, it is supporting synchronous demodulation, and it is doing that in the very, very early years of this being practical. So it's quite interesting that it's doing that. And the other reason that it's interesting is because this is a measurement demodulator. So rather than just being built as cheap and nasty as possible, this is really no expense spared whatsoever. And if we look at the price tag of it here, we've got £11,000 and a bit. This is back in the early 80s, so yeah, presumably similar price back in the 70s. Yeah, so this would have cost about as much as your house, so certainly not something you would just be slapping in your TV cabinet to receive television with. Now, the actual design of it will be, I would say, extremely good. Everything about this product will have been honed to absolute perfection, and the reason for that is because its main purpose is for testing TV transmitters. So you want to be absolutely certain that your receiver is as perfect as possible, so you can view the errors in your transmitter, not the receiver. Anyway, I digress. Let's get back on topic here. So I'm fortunately in possession of a few scraps of the manual of the PM5560. I don't have the full thing, but a few pages from it. And this here is the demodulator unit. It's really interesting to see how this is actually built. Now you might be expecting that we might see this TCA 270 that we just looked at, but yeah, it's not on here. This demodulator is really just built from a large number of discrete components with some amplifiers on here, and we can actually see that in the schematic for it here. And yeah, we can see that this is very much forged from raw materials. This would have had to have been done because this item would have been designed in the early 1970s, before there were any integrated circuits. And it just gives us a taste of just how complicated a synchronous demodulator would have been if you were to try to build it back in those very early years. And bear in mind, this is just one of many PCBs that would be inside this piece of equipment. I don't even know how many there would have been, possibly as many as 15 of them. There would have been, let's say, even just in the demodulation process, there would have been several other PCBs that were supporting this one. So yeah, really just quite an extraordinary device, and really a hell of a lot of engineering would have gone into that. In today's video, we're going to be looking at 3 different TV tuners stroke demodulators. Now, these are all completely analog, and superficially they all do exactly the same thing. However, they all have completely different purposes. Now, first up here we have our Arcam Delta. Now, we've seen this thing in my videos before. Now, this is going to be representing our ordinary consumer receiver category. And next up we have this Showman 5000 series from Broadcast Technologies. This is a broadcast monitoring receiver. And finally here we have this Rohde and Schwarz measurement receiver. This is the EMFP model. Now, this is equivalent to the PM5560, which we talked about in the introduction. However, it is about 15 years newer, and certainly I'm hoping it might be at least a little bit better. Let's get cracking. Now, I have put together a big old test setup here, and we've got everything that we need to demonstrate the various theories and equipment and what have you throughout this video. Now, I'm going to start off by explaining what everything is here, and first of all we will start with the monitoring setup, which is presently powered on. At the center of it we've got this matrix switcher here, which today is just being used to switch a single video circuit. Its output is connected to the vector scope and then on to the waveform monitor. The monitoring output is then connected onto the TV here, and I've done it that way because a consumer television is a pretty poor way to terminate a 75 ohm video circuit. So that means we terminate at the waveform monitor, so everything is nice and clean. The matrix switcher has 4 different inputs. We're presently looking at input number 1, which is just coming straight from the monitor output of the modulator here. So we're basically seeing what's going into the transmitter directly, and as we can see, it's extremely clean. We then have the output of the 3 demodulators which we're going to be testing in this video. So starting off here with the Rohde and Schwarz EMFP, the measurement demodulator. Then we have the Showman 5000, this is our broadcast monitoring demodulator. And then we have the Arcam Delta 150, which is our consumer demodulator. So the transmitter is powered on, and the first thing that we're going to do is just have a look at the Arcam Delta 150 and the Showman 5000 series. We're just going to make some comparisons between them and see how they actually perform. Now there is just one big caveat here, is that these are both UK models. These are System I receivers, whereas our transmitter is a System BG variety. So there are a few things that we have to do before we can actually start this test in order to be fair to this equipment, because as we can see on the vectorscope, that's not looking very nice. First of all, we have to switch off the FM audio carrier because it's at completely the wrong frequency, and it's not reasonable to expect a System I receiver to have to deal with that. It's going to completely mess it up. Next up, we have to adjust the modulation depth on the vision carrier from the usual around about 10% down to up to 20%. Now the PM5580 confusingly has an inverse measurement, so we're actually seeing 80% on the display right now. Now that 80% means we're using 80% of the carrier amplitude to represent our 100% white test signal, and yeah, this is a pretty good test signal to work with because you know that you're seeing the right thing on the display. Now the extra 20% of headroom is used for the additional level of color saturation which is possible with System I. Now the last thing that we have to do is turn off the group delay pre-distortion feature because that's never used here in the UK. So there we go. Now we've got a valid System I vision carrier with no audio. Now that's looking a lot better. If we look on the vectorscope now, we have nice clean vectors and nice clean traces where before it was a complete mess, and that's because the sound carrier was basically leaking into the vision demodulator inside of here because this doesn't have an appropriate filter for a System BG audio. So yeah, looking pretty good, but of course, now if we remember what this looked like when we were connected directly to the TX monitor from our transmitter, it's quite a bit different. So it's worth taking a minute to just explain the differences that we're seeing here. Now as for the luminance, it's actually looking pretty good. We've got around about the right levels here, which is that's pretty good actually, because for consumer equipment, outputs can be pretty random. You know, you get all sorts of weird and wonderful voltages and levels and what have you. But yeah, this is quite good. But for our chrominance, the amplitude of the color subcarrier is a little bit low, but it's not all that bad. I mean, I would say that's probably perfectly acceptable for consumer equipment. Now the real interesting feature on here is actually the way that these traces, rather than being in straight lines as they are for when we connect directly to the transmitter, we have these arcs here. So notice this one here. Rather than transitioning directly from green to magenta, it's actually taking a detour via the deep blue territory, that's pretty interesting. Now this is basically one of the limitations of synchronous demodulation. Now, while it's very good at recovering the luminance very accurately, unfortunately it has its limits when it comes to chrominance. You just, particularly for consumer equipment where you can't be spending loads and loads of money on correction circuitry, you still just end up with a bit of distortion here, but as I say, it's usually not noticeable to the average viewer. Now let's have a look at our Showman. Now straight away we can see some differences. Where the luminance was a little bit over on the Arcam, it's actually basically bang on for this receiver, which is yeah, that's pretty cool. However, the chrominance, interestingly, it's coming out as very rather loud. I'm not really sure what the deal with that is. I had a look in the manual to see if I could understand why this is really just coming in so over, but I'm not really sure. So what this would mean is the colors would be a little bit oversaturated for the output of the Showman receiver. Perhaps this is intentional. I'm not sure. I'm not going to speculate about it, but for the time being, I'm just going to put the vectorscope into manual amplitude mode so we can get things looking pretty reasonable. Now straight away we can see that, like the Arcam receiver, we have this quadrature distortion here, which yeah, unfortunately that's to be expected because the way this receiver is designed is actually quite similar to the Arcam, so I wouldn't expect to see any significant differences there. However, there is one really interesting difference. We can see that if we look really close, if we look at the vectors from the Showman, compare them to the Arcam, you'll see that the Showman, there's a little bit of jitter here. It's just, you can see very, very faint, very subtle. Now the reason for this is because the Arcam is a passive synchronous demodulator, so it's basically demodulating using a carrier tone which is just scraped straight off the airwaves. Because of that, it's very stable, whereas the Showman has an active carrier regenerator inside it, and basically it's re-oscillating the vision carrier tone from scratch and using a PLL to phase lock to the carrier which is coming in off air. And of course, where there are PLLs, there is jitter, which is not ideal, but although the Arcam looks a bit cleaner and a bit nicer, in reality it is better to start with a fresh tone, even if there is a bit of jitter, because if the incoming carrier tone is anyway impaired, of course that's going to be going straight into the demodulation process. So next up I'm going to give these two units just a quick signal strength test, because that's really one of the only things that I can actually really do here. I don't have all of the fancy equipment that you need to simulate all of the various other troubles that you have with TV transmission. So we're hooked up to the Arcam Delta 150 at the moment. What we'll do is just turn down the signal and see what happens, see when it drops out. So as we turn this down here, we see the odd flick on the screen. That's because there's various level switching relays inside our channel converter here. So we're still going, and now bear in mind that our actual signal at the receivers is going to be about 10 dBm lower than what we're seeing from this display here because of the splitting and impedance matching and what have you. So we're starting to look pretty nasty here. Look at that, look at the vector scope and the waveform monitor, completely unrecognizable. And the signal is actually passing through these, so yeah, the TV is actually doing a better job there. So we lost our chrominance, when was that? We'll say about 68, negative 68. And we still have sync though on the TV there, so you can still just see the text. We'll just keep turning it down. Well, there we go, we lost sync to negative 78. Alright, so that's our Delta 150. Now let's switch it over to the Showman and see how that goes. We'll start going from our starting point, which was negative 20. Alright, just adjust that vector scope so we've got the right thing on the screen. Right, let's turn it down. Still going. Oh, we got made to negative 70. Still going, still got colour. Oh, we lost about negative 71. We lost the colour, so it did actually perform a bit better than the Arcam Delta, but we'll keep going. Still just got the sync. Wow, it's just amazing that the TV still can still find something in that signal. And we lost sync about negative 80. So yeah, the Showman was a little bit better than the Arcam, but it's not really anything significant. It's just pretty minor there. So yeah, and the two seem to be performing pretty similar to each other in terms of receive sensitivity. So next up, our Rohde Schwarz measurement demodulator. Now there's going to be some people watching this thinking, really, am I really going to go there? Now the reality is that an instrument like this would typically be used by people who would have trained for years and accumulated decades of the relevant experience. We can't just roll in there and somehow expect to cover all of that stuff that people would have done with this. So what we're going to be doing instead is just kind of giving an overview of it and talking about all of the functionality it has and playing around with it and seeing what effect it has on the output signal. So first of all, let's switch it on. That's a rather dubious message on the screen here. I don't think there's anything about this instrument which is unique to Germany, so not really sure why it says that. Now at the moment we've basically got it in the pretty well ordinary operating mode. If you just wanted to tune this thing into a channel and plug a screen into it and see something happen, this is how it would be configured. Now I've had to readjust the modulator back to system BG mode so that we get the right levels at the output. Now have a look at the vector scope here. Now straight away we can see that the traces on here are quite a bit different to what we were seeing on the other two receivers. They're much straighter, where we had a particular arc. It's definitely a little bit better. So in this very basic configuration, yeah, it does seem to demodulate television quite a bit better than those other two receivers that we looked at. Now I've just dimmed down the light a little bit so that we can see our monitors here. Now one of the first things that I thought might be quite interesting to play with is the demodulation mode. Now we do actually have a couple of options here. Now remember back in the introduction we talked about synchronous detection versus envelope detection. Well, we actually have both modes on this instrument. So if we switch between them, we can see on the waveform monitor in particular that the envelope mode is just, it's just not really all that good. So our synchronous mode here is the correct representation for luminance and the EBU color bars, but when we switch to envelope, it's wrong. The chrominance actually is not so bad now, not all that much difference. Now there is a question of why an instrument like this would have envelope detection if it is considered to be obsolete. Well, there's various answers. First of all, it's just kind of cool to be able to see how an envelope detector can receive things, particularly if you want to see how people with TVs from the 1970s, what they're actually looking at. But there are various measurement reasons why you would want to have envelope mode. Envelope mode is a wider bandwidth, it's much more tolerant to phase noise. So depending on what sort of test you're actually doing, the envelope mode might be quite useful. Now the next feature that I want to talk about is the sound trap. Now of course we have a option in the menus here to switch it off or on. Now it's presently on, but if I switch it off, have a look at the chrominance here. All of the traces changed, so why is this having an effect on the video if it's something to do with sound? Well, what this is basically doing is activating and deactivating an optional filter in the demodulator which blocks the sound subcarrier. And of course by adding a filter we alter the characteristics of the demodulator and therefore distort the video signal, which is why you can switch it off or on. Now if we switch the audio subcarrier back on at the modulator, we can see that the sound subcarrier is now flooding into the vision demodulator and it's completely destroyed the chrominance. But of course you can fix that by switching it back on again, and it's now all nice and filtered out. It does take a little while to stabilize. But yeah, anyway, that's what the sound trap is for. So if I switch the sound off again, now you do see a little bit of distortion temporarily, and that's actually the Philips modulator stabilizing and what have you. But yeah, anyway, so that's the sound trap for you. Now next up I want to talk about the relationship between the sound trap in this unit, or the IF sound filter, and the group delay pre-corrector in the modulator. And we talked about this back in my very first video. Now this next bit is really just specific to System BG. I don't actually know what the situation is with System I. To the best of my knowledge, group delay pre-correction wasn't actually used. So what we're first going to do is turn off the sound trap, which is in this menu here. Now I'm just watching the chrominance when I push this button. So the shape of those traces just changed, and arguably it's actually worse than it was before. But if I turn off the group delay pre-correction at the transmitter, it takes a little while to restabilize. Look at that. Actually it looks pretty good now. It looks almost perfect. So that's quite interesting, and what this suggests to me is that group delay pre-correction in part is intended to correct distortions which arise from IF sound filters. It's possibly not the only thing that they do, but that certainly does seem to be a significant factor. Now the very last thing that I want to talk about is the SAW filter. Now I just realized I've actually had it switched off throughout all of these tests. But if we actually go into the menu, we once again have an option to switch it off and on. You'll notice that it does absolutely nothing. So to understand this, we need to talk about what it's actually doing. So the SAW filter sits just before the demodulator, and this decides whether or not the demodulator is receiving just a single television channel or absolutely everything. Now in the case of a consumer receiver, a feature like this is always going to be turned on. They're always going to be constrained to receiving just one channel. But it's quite interesting to be able to switch it off and receive everything, because there are some interesting tests which we can perform which are basically impossible on a consumer receiver unless you want to take them with a soldering iron. So we'll switch it off. Well, it is already off. And what we're going to do is run through and switch off all of the other stuff as well. So the sound trap, we'll switch that off, make sure that's off. And our demodulation, we're using synchronous. So we're in a pretty good situation here. So let's just go out of here. Now what we are going to do is switch the modulator into double sideband mode. Now look at that. We'll just adjust that modulation depth. Look at that. The receive signal is now almost exactly the same as what's actually headed into the transmitter. So I can actually just switch that over right now and we can have a look. So I've just switched back to the test pattern generator. Look at that. So that's the original input signal. Now if we switch back to into our Schwarz again, look at it. So yeah, that's really nice. And this really reveals one of the most interesting things about vestigial sideband modulation, is that it really is the thing that is responsible for the distortion that we see in the chrominance, which is very difficult to correct. So if we can just switch to double sideband mode and just cut out that IF filter, wow, look how nice it is. Now, unfortunately, in the real world, this was not really a possibility because, as we said back in the introduction, double sidebands are enormously wasteful of radio spectrum, so completely commercially impractical. But certainly from a testing standpoint, very interesting and very, very cool to see such a perfect signal come out of a demodulator. So let's have a look at some receivers. Now, first up we have the Arcam Delta 150, which we looked at back in the NICAM video, I believe. I can't remember if we took the lid off or not, but yeah, today we're just talking about the video section. There's really nothing special about this thing at all, but I do keep it around because it's really just very, very typical of a 1980s television. It's just, everything in here is, the tuner and demodulation section is pretty well exactly what you would find in one of them. And maybe there's a little bit higher quality, but it's not really anything significant. Now the tuner here is just this one, and we also have a remodulator. The IF filtering, just ordinary SAW filter there, and our demodulator is this TDA8341. Now this is a synchronous demodulator which is descending from that TCA270 which we just talked about, but yeah, the output of that just goes basically straight out the back of it, nothing else going on here. Now next up we have this Showman 5000 series. Now this is actually a British item, and yeah, considering that the UK is my #1 audience demographic, we should be having some more of these. Now this was actually sent in to me by a good friend, and I'm very thankful to have this here because this is not really the kind of item that you're going to be finding on eBay these days. Now it's actually coming to me from its original situation, but despite that the manual unfortunately had been lost. Now there is actually a company here in the UK which is somehow connected to the one which originally marketed this. This is Broadcast Technologies. Now I actually emailed them and asked them if there was any possibility they might have some documentation for this, and they actually responded to me with an electronic copy of the manual for this 30-year-old product, which that was just completely unexpected. So this company gets my very biggest thumbs up. Now, being in possession of the manual, we of course can talk about all of the capabilities of this unit in detail. Now we have 4 outputs here for video, so these are labelled vid 1, 2, 3, 4, and these are all separate 75 ohm sources, so you can connect this to 4 different monitors or other pieces of monitoring equipment or whatever. In its original situation, I'm told that yeah, it was connected to monitors around the studio and potentially various other maybe sync level monitoring and what have you. So yeah, quite nice that they have 4 of them, and means you don't need a video distribution amplifier. Next up we have the antenna input. This is a 75 ohm F connection. This is indicating that this unit contains a consumer tuner, which is to be expected for what it is. Next up we have the IF output. Now this is a very nice connection to have. So you could use this for various things. So you could connect a spectrum analyzer to it, so you can have a look at your channel that you're receiving and just flick through the various channels on the tuner with this unit, so you don't have to retune the spectrum analyzer. You could also use this for remodulation, so to remodulate the output up to a different channel. PM5690 is a piece of equipment that I have here which will do that very nicely. You could also connect this to another demodulator, like a precision video or audio demodulator. We've got a few of those kicking around here for some specific tests. The other thing we have on here is the audio outputs, 4 of them, which might seem a bit overkill, but remember that this thing supports NICAM and A2 stereo, so I think it works out that the NICAM would come out of these connectors, and the FM or A2 stereo would come out of these 2 connectors here. Next up we have the QPSK output. This is a fairly esoteric connection. That's the NICAM intercarrier output. You could connect that to a NICAM tester, like one of those Philips units we've seen on my channel in the past. Sin and cost, this will be kind of cryptic there. This will be the Arcam I and Q channels, so you would connect that to an oscilloscope for eye height measurements. Next up, we've got in DAT and clock, so Arcam Data and Arcam Clock, which, as I said, we've talked about all that stuff before. The last one on here we have is DORD. That's kind of a cryptic name there. I had to look at the manual to see what that was. So this is an AES EBU style audio connection there, digital. And we've got two control interfaces. So we've got a parallel control and a serial control. So that's RS232. You can send some very basic commands in here to configure it. It's same with parallel. There's this kind of GPIO type arrangement where you can send some voltages in here and it'll do stuff. But yeah, not really very capable. This unit has a successor, the Showman 1000, which is way more capable. It has a very fancy serial interface with all kinds of stuff you can do with it. It'd be nice to have one of those here, but unfortunately we've only got this older unit. All right, we are in. Now, unlike that Arcam receiver, which had this kind of consumery feel about it, this is like, yeah, this is quality. I really like this. So we've got a nice FR2 PCB, really well made, and you know, really high quality components throughout. I don't really see many electrolytics in here, so that's really very good. Notice that we also have an integral power supply cover. That's a good feature. A lot of times equipment like this is run with the lid off, and a lot of people just can't seem to be bothered with safety, so you've got exposed mains all over the place. But yeah, this unit is completely safe with the lid off. I like it. Now the actual design of it, like the Arcam, it's quite Philipsy. You can see Philips parts all over the place, particularly doing all the really key functions. Our tuner here. No brand name on there, but that looks like a Philips part number to me. Our demodulator here is a TDA9803. Now this one is a bit different to the one of the Arcam. This one actually has active carrier regeneration. So yeah, I like that. That's quite a nice feature to have that there. And we also have this empty footprint here. This is another very interesting feature that you won't find this in a consumer receiver. So this is for an optional group delay equalizer, which is would flatten out the group delay profile of this receiver if you had it. Presumably produce a pretty nice output, but yeah, sadly I don't have it. I've just got a jumper that bypasses it. Now after that we have the video output stage, pretty beefy here. We've got transistors with heatsinks on them. That's pretty hectic. I don't know if that would be entirely, well, maybe it's necessary, I don't know. I suppose there's 4 outputs there, so yeah, then you have a bit of current to deal with. Now we do have some other demodulation chips. We've got that's a dual FM audio demodulator, so that would do either mono or A2 stereo. We also have the pilot's tone decoder there. That's a TDA8415. So this would decode the A2 stereo pilot tone and instruct the various logic in here. I'm not actually sure what it would do. Certainly tell it how to switch the audio signal, so if you have dual or stereo modes or whatever. More information about that back in video number 3. And after that we have all of our various Arcam stuff in here. So there's this is the Arcam intercarrier filter, which is just a little weenie consumer Toco filter. But notice that we have a footprint here for some other item which goes in the space of this. Now this is actually for the PAL BG model. It says in the manual that the intercarrier filter for Arcam in that unit also has a group delay equalizer on it, which is like, oh, okay, I've never seen that before, not in any consumer equipment. So yeah, I'd really be interested to know why that was necessary, but I don't have that on here. And after that we've got our Arcam demodulator here, TDA8732. That's quite an old chip, that one, from about early 1990s, 1991 I think that came out. And down here we have our Arcam decoder and DAC, so that's an SAA7282. So yeah, that's containing the Philips 1-bit DAC, which of course everybody will have heard of. And what else have we got here? Various other chips for the outputs here. So we've got this is the AES EBU connection there. There's a buffer on that, and that actually comes off that Philips Arcam decoder there. So that's a nice little freebie that they've made use of. It's pretty cool. And yeah, this is just the microcontroller, so Philips 8051 keyboard decoder, and nothing else really all that interesting here. So yeah, that's the inside of it. It's a pretty nice unit. I really quite like this. Next up, the Rohde Schwarz. Now, I actually had to make this entire video with no documentation for this thing whatsoever, not even a spec sheet. Now, I did actually contact Rohde Schwarz UK on the off chance they might be able to send me anything. I did receive a response from them. They were very friendly, but what they told me is that the company does not have any electronic records of this product. I'm not sure if that means this was designed on pencil and paper. It certainly doesn't really seem to look like it. Now, presently, I've got the base detached from it, and if we have a look at here, there's actually this really big, nice copper shield on here. I'm not really sure what that would actually be used for, but yeah, you can slide that out of there and maybe use it in self-defense or something. The previous owner certainly seems to have found a use for it. We've got some handwritten notes in German on here, which looks like they've been rubbed off. But yeah, anyway, let's whip the lid off this thing and have a look what we've got inside. Alright, we've got the lid off, and yeah, straight away we're greeted with the just usual Rohde Schwarz overkill build quality here. Just smacks you in the face. You just look around at it all, just the precision of everything is absolutely eye-watering. Now, often, as is the case with old TV equipment, the only documentation you're ever going to see is what's written on it. Now, fortunately, we do actually have some pretty good explanations of everything that's inside of here. Now, in the past, you might have noticed I've been a bit frustrated with you know, just the general construction of these things and the serviceability of them. Now, this one is a bit better than what I've seen before. However, it does have a sting in the tail, which we'll get to later on. But anyway, let's go over the block diagram here, because this gives a pretty good explanation. Now, this top module here is without question the demodulator. Then we have our IF or ZF inputs here, and this is presumably coming up from the tuner, which is going to be underneath here. Now, those signals are heading in two different directions. First of all, they're headed off to what looks like some matching circuitry for the sound demodulators. So the sound carriers will be exiting from this assembly down to sound demodulators below. And we also have the Vision IF, which heads into the rest of the demodulator, and we even have arrows on here explaining the flow of all the signals, which is pretty cool. Now, we first start off with this mysterious filter section. Not sure what that is. Maybe this is just like some very vague low-pass filter or something, just to get it in the right ballpark. Not actually sure. And then we have the sound trap. Now, we do know what that is. Of course, we talked about that before. After that, we're heading up to this all-pass filter. Not sure what that is actually. It's actually not the same thing as one of these, but it will be making some adjustments to the signal. This could be like a group delay equalizer or something like that. Potentially some Rohde Schwarz special source. Now, remember, we saw that this thing demodulates video a bit cleaner than the others. That might be because of this here. I'm not sure. Now, after that, we have the Nyquist filter. Oh, I actually forgot to talk about Nyquist filters back in the introduction. Let me grab this scrap of paper. I do actually have it here. Where is it? Here we go, this one. So, remember back in our introduction, we talked about vestigial sidebands. So, the Nyquist filter is basically... remember that we have a vestige of the lower sideband here. It isn't completely attenuated off. So because we have both sidebands of this portion of the incoming signal, the amplitude of this section of it does end up quite a bit higher than the rest of it. I think it's like 6 dB or something. So when you demodulate a vestigial sideband, say you end up with very loud down here, but this is all a bit quieter. So the Nyquist filter is just really just to equalize all of that out. Yeah, I'm probably getting into too much detail there, but anyway, that's what that is. Now, after that, we go. Oh, it looks like we have another ZF IF bandpass filter, which is heading into the envelope detector, which we talked about. But it's also we also have a path heading up to the synchronous demodulator here. So yeah, there's our two demodulators, which the unit allows us to switch between. After that, we've got, looks like the output is down here, so we've got, that will be the baseband video signal coming out on this coax down here. So it looks like looks like we've got everything here. And over here we've got an analog plat. I'm not sure what that is. Maybe concealing some mysterious analog goodies. I think we're going to have a look under there. And we'll have to have a look under here as well, actually. Let me go and grab the cordless screwdriver. And just like that, we are in. Now, when you're screwing down a lid like this, it's always important to use at least 100 screws, because you never know when something's going to sneak through that fraction of a millimeter gap, especially when you have frequencies of like 40 megahertz. Now, looking in the inside of here, once again, we can see this just really crazy quality here. I mean, look at these trimmable inductors. They look like they've got machined cans on them, for goodness sake. This thing is built like it is going to the moon. I mean, just the quality of it. It's really, really crazy. Now, in terms of the actual design of it, it looks, for its era, it looks rather dated, actually. I would estimate this unit to be maybe early 90s, because it knows about the NDZ Arcam Demodulator, which that would be coming out about that time, so it can't really be much older than that. But yeah, it looks like a much older design, actually. Now, I know there is an older predecessor to this piece of equipment, which has a more analog front panel. It's quite possible that that thing is actually is basically the source of a lot of the design for this, and possibly actually very similar internally. And that item, I think, probably did compete with the PM5560 that we just talked about. And this one, from what I've seen so far, does appear to be of a very similar design. But yeah, I mean, otherwise it's got all the kind of stuff you would expect. We do have some integrated circuits down the back here, but they all look pretty basic. We don't have anything fancy. So it looks like the synchronous demodulation has been done, I would say, by a fairly verbose method, where they've just done it with fairly basic components. And of course we have the usual Rohde and Schwarz, absolutely ridiculous level of shielding, everything all isolated to ridiculous levels, so yeah, that's to be expected. We've got a rigid coax, always nice to see lots of those, and it's like this thing is like a microwave design or something. Now, the other thing we've got under here is the analog plat. What's under there? Oh, look at that. We've got, what on earth is that? It looks like we've got a couple of, I would say these are, yeah, those are probably balanced audio output transformers. And that's going to be the amplification circuitry for it there. And given that we've got the speaker there, I mean, that's got to be what this is, right? And this is the reason why I wanted to find one of these older units, because I really love these old through-hole designs. You know, it's kind of a bit boring when everything is just inside of a DSP or something like that. So now it's time to get down to the next level, which is just a case of lifting up this heavy, over-engineered module and clicking into place just like that. Now, one of the weaknesses with this equipment, because these modules are so bulky, they have an unfortunate tendency to shear off the 2-3mm mounting screws at either ends during transit. That actually happened to another piece that I bought some time ago. That was quite frustrating. It took me quite a while to repair that. But anyway, we're in now. So this big module down here is the tuner. I bet you've never seen a tuner that large before. So let's quickly run through the diagram here and try and work out what's going on. Now, our inputs from the rear are coming straight here, so this is where you're going to have the attenuation, matching and switching between these inputs. We've got a filter down here. I'm not sure if that's passing through there or not. Don't know what that's for. After that, we've got our first down conversion, then our second down conversion, and of course the oscillators for each. They may be phase locked to this 15 megahertz oscillator here, I'm not really sure. We've got various filters on here, so this 1 gigahertz bandpass filter, this probably will be the filter that sits after the first down conversion. We've got an IF bandpass filter there, that's going to be the one that sits after the second down conversion. That presumably goes through this amplifier, which is probably a preamplifier for the SAW filter. The SAW filter is the one that we talked about in the demonstration, which constrains the IF output of this to 7 megahertz in this particular case. After that, presumably we just head straight to the IF output here. There's another couple of things here. So we've got a IF vision oscillator. I'm not sure what that's for. Maybe it's something to do with this this one here. Only a dozen screws? Is that all you got for me on the tuner? Oh, well, let's take the lid off. Well, there we have it. There's the all the various RF goodies in the tuner section. Let's have a look at it all. Looks really, really nice. Oh, very high quality components there. Lovely. Look at that. We've got a mystery metal box under here, what's that? That's the first oscillator. Oh, this is something very precise looking with a Rohde and Schwarz logo on it. That doesn't look like it wants to be opened up. Yeah, look at the input section here. I love these air core inductors all squished into weird and wonderful shapes, and they've got these center taps manually soldered into them. Gosh, someone's spent a good long time making that all right. And our saw filter is actually just that one under there. I'll just show you a picture of that one. It's quite a big, long, funny looking thing. I've never seen something like so large. Right, it's time to get on to the next level, and we have another big, heavy module to lift out here. Click that into place. Right, so this level is looking quite a bit different to what we've seen before. It's actually rather more open. So what we have down here is the sound demodulation and testing. Now this unit is supporting A2 stereo or Zweiton, so yeah, this is going to be fairly complicated. So it's not just demodulating it, it has to have all the various stuff in here to actually test whether or not those carriers are being modulated correctly, including that pilot tone. Now I have discovered this unit is quite good at checking whether or not your pilot tone is correct. Now remember I said there was a sting in the tail, so if you look here there's a capacitor flapping around here. Now when I first turned on this unit I was greeted with a plume of smoke, and it turned out that this capacitor here had gone short circuit. I've never seen an electrolytic go short circuit before. Apparently being West German didn't save it. And that caused this current sensing resistor here to release the magic smoke. That was one of the things that kind of let me down about this instrument. The serviceability, as I said, is quite good with these folding out modules, but that power supply is really hard to get out and even harder to take it apart. So that was really frustrating that the one part of it that I actually had to look at was the most difficult to remove. I'm sure the service manual tells you in exquisite detail exactly how to take this apart, but yeah, I don't have that information. I probably have a pretty good idea now, having spent hours swearing and cursing, but yeah, it would have been nice to have had that up front. Well, anyway, that's as far as we're going to go today. The only other thing down here, which I'm not going to bother opening, is this one here. I think that's where the microprocessor and all digital control is under there, because that's the only thing we haven't seen yet. So let's have a look at our connections on the rear. Now we have two RF inputs. We've got a 75 ohm input, which we would find on any kind of receiver. We also have a 50 ohm input. Now this, when you see one of these, you know you're looking at a serious bit of kit. We also have ZF inputs and outputs. The IF output, this is, as I say, this is the same feature we would have on the Showman, but we also have an IF input. That's a very, very professional feature, and you would expect that because adjusted for inflation, this thing probably would have cost like 30,000 euros. We also have another bank of connectors here, so we have an looks like unused connector here. We've got the 0 ref pulse input and the Q signal output. Now that's going to be, I presume this is going to be the quadrature output from the synchronous demodulator. Now these two connections here, I was thinking about covering them, but this video just got a bit out of hand, so we ended up skipping them. The really important one though, of course, is the video output here, a 75 ohm, just a regular 75 ohm video output. This X2, mysterious connector, but this will probably just be a bunch of monitoring GPIOs or whatever. NDZ only, I'm presuming this is referring to the Rohde and Schwarz NDZ NICAM demodulator, which for some reason wants to be attaching to this item with a large umbilical cord, a DC37. I did check that there is one of those on the back of that item. We also have, this is our balanced audio outputs and the GPIB interface here. And of course we have the usual Rohde and Schwarz mysterious spigots. I've got these things poking out of every single Rohde and Schwarz piece I've got here. I have no idea what they're on there for. If anybody knows what those do, let me know in the comments. Well, that's all for today's video, and I hope that you found this interesting. If you have any further questions, put them in the comments section, because inevitably people who know a lot more about this than me are going to be watching this and probably able to even answer them for you. But anyway, that's all. Thanks for watching.